7. So you can check, you can identify easily in terms of which are the wrongly predicted values. So if you calculate the wrongly predicted values, total how many wrongly predicted values are there between the Y-pred test versus Y-test, between the Y-pred test versus Y-pred. Okay. So if you check this two of them, if you observe these two of them, that is Y-pred test versus Y-test values. And if you identify the wrongly predicted values, or if you take the data like this, and if you start calculating, so these many values calculating means manually, it is somewhat difficult. Again, I have to write the code. Now, if I start writing the code means, again, you get confused. And with respect to, sir, what is this minus and why you are doing this one? Again, you'll ask these questions. Instead of all these things, just if you observe this one, it is just identifying how many records are having the same answer. Just it is checking the accuracy. And out of which it is identifying the, in the original here, actually, this is the predicted value, predicted 0. But what is the actual value? Actual 1. It is actual 1, predicted 0. So in the confusion matrix, what happens? This one, if I take the predict this side and actual this side, 0 and 1, 0 and 1. Now this particular record comes under which category? Predicted 0 and actual is 1. Actual 1, predicted 0. So in this category, it is going to be counted. So like this, we are going to identify the how many of them are wrongly predicted, how many of them are correctly predicted. And based on that, it is going to create the confusion matrix. If you are interested, you can do manually also. Start doing manually. But it is 154 records now. So 154 records means it will take time. That is the reason, for simple example, I have taken the 10 records in the previous case and I have done, instead of doing here of 154 records, right? Now, once I can do this one without doing this here, the confusion matrix, without using the word confusion matrix also we can do, but I have to write the few lines of code. Again, if I write that lines of code, again, you get confused and there is no use of also that. There is no use of that. If you are interested, you can convert. If you are interested, you identify, you write the code for that as per your requirement. So now confusion matrix I'm having. Sir, in this confusion matrix, this is the actual side and this is the predicted side, and this is 0 and 1. This is 0 and 1. If you want to see that which is actual side, which is the predicted side, means here you can't, it is not going to display. But there is one more option called as from sklearn.metrics, import the plot confusion matrix. We are having with respect to plot confusion matrix. Now plot confusion matrix we are going to use, and inside that we have to write the model name. Inside the plot confusion matrix, we have to write the model name and X test and Y test. Now what it is going to do means it is going to predict the X using the model. First, it will predict the values. After predicting the values, it will only do using this X test. First model. What is the model name? Log underscore default. Using this log underscore default dot predict on X test, and it will calculate what are the values it has got, and these values will be compared with the Y test. In the backend, it is having that one. In that way, it will do. So, and I'm going to get the plot confusion matrix like this. Now here, plot confusion matrix from sklearn.metrics. Cannot import the name plot confusion underscore matrix from sklearn.metrics. Okay, so I think they have removed earlier. We used to have some warning, but I think they have removed it. Okay, just ignore this one. Okay, you can ignore this one. And here you can see this. This is called as actual side, and this is with respect to predicted side. And this is 0 and 1, 0 and 1. You are going to get 0 and 1. And next one is classification report. From sklearn.metrics, import the classification report. And in the classification report, you have to give the Y test versus Y pred test. Okay. And you are going to get the values in this way. Okay. So this one, the first one indicates the precision of 0. This value indicates the recall of 0. Similarly, this one indicates the precision of 1, and this one indicates the recall of 1. So you're going to get the precision and recall by using a classification report. By using the classification report, you can calculate. And similarly, you are having the F1 score, one of the important metric in the evaluation of classification, F1 score. Now, what is meant by this F1 score? F1 score means nothing but average of, it is going to take the average of precision and recall. Average of precision and recall. Now, what is the average? Which average it is going to consider means it is going to apply the harmonic mean. It is going to apply the harmonic mean on precision and recall. We are having 3 types of means, out of which first one is called as arithmetic mean, which is nothing but simply in our case average. We used to call it as average. Second one is called as weighted mean. Do you remember in the descriptive statistics we have discussed weighted mean? Means different records are having different weightages. Then we are going to apply the weighted mean. And the third one is called as harmonic mean. And the fourth one is called as geometric mean. Total 4 types of means are there. Out of which we are going to apply the harmonic mean over precision and recall is called as F1 score. F1 score means harmonic mean of the precision and recall. Now the question will be there. Sir, why we have to apply the harmonic mean, and in which cases we have to apply harmonic mean, and in which cases we have to apply the arithmetic mean? Now the simple, for this question, very simply we can understand. Let me ask you a simple question, that is A plus B is equal to C. Assume if A plus B is equal to C, then A is equal to C minus B. Is that okay? For everyone else, okay? Any problem? If A plus B is equal to C, then A is equal to C minus B. Is that okay? Or anyone has any problem? No problem, right? Now, 100 plus 10%. For 100, what is the 10%? Just 10. 100 plus 10, what is the answer? 110. Now, 100 is equal to 110 minus 10%. For 110, what is the 10%? 11. Now 110 minus 11, which is equal to 99, is 100 is equal to 99. As per this logic, this has to be completed, right? This logic will fail if you are having the percentages. When you are having the percentages, this logic we can't apply. There is a problem in this. Now, since you're not satisfied with the one example, I'll try with one more example also. Okay, let us try with one more example. Let us assume you are having the 100 rupees with you. Okay, in first year, you got a profit of 10% on whatever the money you are having. Second year, you have got a profit of 20%. Third year, you have got a profit of 30%. Now, what is the average profit you have got? If I ask this question, everyone will say 10 plus 20 plus 30 divided by 3, which is 20%, which is a wrong answer. Which is a wrong answer. Why? Because first year you are having basically 100 rupees with you. First year you have got a profit of 10%, means 10 rupees is the profit. Now 100 rupees with you plus 10 rupees. Total amount is 110. Now second year you got a profit of 20%, not on the original amount, on this one. Now 110 is already with you. For that you are adding 22 rupees. That is 22 rupees. Now the amount is 132. Now for 132, you are adding the 30% of 132. What is 30% of 132 miss? It is 39.6. 39.6 if you add, now you are having total 171.6. Now total amount, what is the initial amount is 100 rupees. Now you got 71.6 rupees as the profit. Now 71.6 divided by 3. Now which is your, what is your profit miss? This is your profit. Correct only? Calculation correct only? 132, 110 plus 20% means 22. That is 132. 132 plus 30% of this means 39 and 0.6. Okay, 0.6. 9 plus 1. 171.6. So you got the 71.6 rupees as the profit over the 3 years. Now, if you divide this profit by 3, yearly, what is the profit you have got now? That is 71.6 divided by 3. What is the profit approximately? 20. So that is the profit percent, what you have got. Now, whatever you have done here, that one you have done is like this: 100 plus 10, which is 110. Again, 100 only you have kept with 20 and now 120. 100 only you have kept and you have got 30 and 130. Now total it is with respect to, you have got the overall profit. What is the overall profit you have got miss in terms of 10 plus 20, 30 plus 30, 60 rupees is the profit. 60 rupees divided by 3, which is equal to 20 rupees per year. And you have taken 20% is the answer. This one you have done the calculation. Basically, you have done the 10% for the original amount, not for the added amount. Right? So whenever there is a percentages, we can't go with the arithmetic mean. Why I have told you this example miss, whenever there is a percentages, we can't go with a normal arithmetic mean. In that case, we have to go with a harmonic mean. So now what is meant by harmonic mean miss? For example, A comma B. For this, if you apply the arithmetic mean, then A plus B divided by 2. This is called as arithmetic mean. Now for the same A comma B, harmonic mean is equal to 2 into AB divided by A plus B. That is nothing but which is equal to 2 divided by A plus B divided by AB, which is nothing but 2 divided by A by AB plus B by AB. AA cancels. AA cancels, that is 1 by B. BB cancels 1 by A. That is 2 by 1 by A plus 1 by B. This is called as harmonic mean formula. Harmonic mean formula is 2 by 1 by A plus 1 by B, or which is also equal to 2AB divided by A plus B. When you have to apply this logic means when you are having with respect to the percentages. In that case, we have to go with the harmonic mean. So here the precision and recall, both of them are percentages. So average of percentages, when I have to take that one, so I have to apply the harmonic mean. So if you apply the harmonic mean, this F1 score, whatever the F1 score is there, this is the harmonic mean, that is 2 into 0.84 into 0.92 divided by 0.84 plus 0.92. These two values, whatever the two values you are having. Similarly, this value is harmonic mean of these two values. Okay. For class 0, this is the precision. For class 0, this is the recall. For class 0, this is the F1 score. Similarly, for class 1, this is the precision. For class 1, this is the recall. For class 1, this is the F1 score. Is that clear? Next, we are having the AUC. The next one is AUC. Now, what is meant by AUC? plot 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 or VOC curve. Just a minute. Yeah, I'm getting this AUC score directly instead of the curve. Instead of seeing the curve directly, I'm getting the ROC AUC score itself. So I can import directly ROC underscore AUC score. Okay. In my case, it is not showing that curve. Okay, there is a problem in my system. It is not the problem in your system, guys. It will work for you. There is a problem in my system. Recently, one problem I have got that some error and some of the files was deleted. So I'm going to modify that one in the tomorrow's session. I mean, in the tomorrow's at home, I'm going to modify that one. In meanwhile, you can calculate this AUC, that is ROC underscore AUC underscore score. You can calculate the AUC score by using the ypred underscore test comma or y test. You can give the y test. And you are going to get the AUC value, directly area under the curve value. Right? Is that clear? So here, first, once again, I'm explaining this one, whatever we have completed. Just once again, I'm explaining. So here the model, whatever the first I'm going to apply the logistic regression. From the logistic regression, I'm going to calculate the accuracy score. Okay. And that is train accuracy, test accuracy versus and cross validation score. After this, confusion matrix. In the confusion matrix, you are going to get the actual value versus predicted values and 0 and 1, 0 and 1, right? So just in your case, I'm going to upload in the drive directly the PDF. Okay. So I'm going to upload the PDF. Just you guys, please practice, and for you, it is going to work. I'm going to upload the PDF, similar kind of whatever I have uploaded for the previous batch, I'm going to upload for you. So in the So this is the confusion matrix where you're going to get the confusion matrix. So in the confusion matrix, you are going to get actual and predicted side and classification report and plot ROC curve means it is going to plot the ROC curve. Whatever the yesterday we have discussed, that is TPR versus FPR. So it is going to take the relation between TPR versus FPR at various threshold settings, and it is going to draw the ROC curve. In my case, it is not showing, but for you, it will show. And once you plot this ROC curve, directly you can see the AUC value also. Okay, this is the curve between the TPR versus FPR. And you can see the AUC value. In my case, it is not working, but for you, it is going to work. Okay, if for you also it is not working, miss, just I will check once again what is the problem, and then I will tell you the answer in the tomorrow's class. Okay, generally we are going to identify the higher the AUC, whichever the model is having the higher the AUC, the better the model. Generally we require only the AUC. Anyways, we don't require this ROC curve. If the ROC curve is like this also, if the ROC curve is like this also, finally we have to calculate AUC value on. So whatever the AUC value is there, the higher the AUC, the better the model. Why AUC means better the model? If the AUC is high means what happens means for various threshold settings, if you change the threshold also, the impact will be very low. That is the meaning of that. The higher the AUC, the better the model means as the threshold changes. Now, what is the threshold for this example? Whatever we have done till now, what is the threshold? Threshold is 0.5. By default, it is going to apply the 0.5 is the threshold. So if you are having with respect to, if you change the threshold, as the threshold changes, how this impact is going to be, right? How to check the threshold means by default, it is going to have the threshold of 0.5. And if you want to predict the probability, so here I'm using my model.predictor on xtrain. Now, if I predict on xtrain, directly if I'm predicting on the xtrain, now see you got with respect to zeros and ones like this. Or if you're predicting on xtest means, let us take on xtest, and you're getting zeros and ones. But instead of predicting directly, if you ask predict underscore proba, if you ask predict underscore proba, means it is going to predict the probability. It is going to predict the probability. See, this is the probability of class 0. What is the probability of being as a class 0? And what is the probability of being class 1? Now, what is the first record probability? Which one is high? 1. So it is predicted as 1. Probability of this one is, so just if you calculate one of them, automatically second one is 1 minus of that one only. Nothing special, right? So now this one, forget about this one. Tell me directly this one. Wherever the value is greater than 0.5, it is considered as class 1. Wherever the value is less than 0.5, it is considered as class 0. Just ignore this. Whatever you are having this. Or simply let us take like this. I'm using the all the columns, all the rows. So just ignore this one. Just by ignoring this one, the first column, just focus on the second column and tell me what is the class. This is class 1. This is 0. This is 0. This is 1. This is 0. Okay. So 1 0 0 1 0 0 1 1. You are having something like this, right? Now, if you observe this, with instead of writing the proba, if you write like this, so same answer you can see. 1 0 0 1 0 0 1 1 is the same answers. So by default, it is going to consider the 0.5. So if you want to change the threshold value, then what you have to use is proba. If you use the proba, and after using the proba, now you have to take the first column. For the first column, wherever the value is greater than 0.5, by default, it is considered as class 1. You have to change this threshold as 0.6. If you want to change to 0.6 or 0.7, means you can change manually in that way. And then you can save that one in the YPred. Now the YPred values will be changed according to the probability. Is that clear? So you know how to write the conditions. So this is an array. You know how to write the conditions for an array using the conditions, how to extract the data. Already you're familiar with, right? Or if you want, you can convert this one as a pd.data frame. I'm converting this one as a pd.data frame. After converting this one as a pd.data frame, now if I want to select only the first column, how to select the first column? By using what? By using column number 1. If you want to use column number 1, how you are going to write? Just by using with respect to 1. So you are going to get this one. Now, once you have got this one, now wherever the value is greater than 0.5, if you want to identify, it is identifying like this. And if you want to extract the data points, means wherever the values are true, if you want to extract, means first what we have to do, this one I'm going to store in a df, some name called as df of your choice. Create one name of f is equal to. Now within that f of f, wherever the value is greater than 0.5, you are going to consider 0.5. Now you are going to get these data points. Now these data points will be converted as class 1 and remaining data points will be considered as class 0. In that way, it is working in the backend. No need to do anything manually. Automatically, it will be done automatically. By default, it is taking as 0.5. Right? It is extracting the data points which are greater than 0.5. It is just filling the values with 1, replacing the values with 1. Wherever the values are with respect to less than 0.5, it is replacing the values with 0. After replacing the values with 0 and everything, and this is the final answer. Whatever the final answer is, that will be stored in the variable. In that way, it is creating. Is that clear? So it is first calculating the probability values. From that probability values, it is working in this way. Is your question is clear? Who asked this question? Prasanna. Is that clear? How to check the threshold? Threshold means in terms of you are going to have by default, it is 0.5. If you want to change manually only, you have to change that one. Clear, guys? Still any questions? And remaining you can ignore. This all of them you can ignore. This column and this whatever you are having below part, everything you can ignore. These are not important as of now. We'll see in the further. Just you can ignore, right? Support in terms of nothing but total number of records of this one and this one. Total how many records you are having in terms of test data. This is for, I have applied for the test data only, right? If you apply ytest.shape, ytest.shape, if you ask total 154 records are there. Out of these 154 records, how many of zeros and how many of them ones miss? 107 are 0 and 47 are ones. That is the meaning of this. Total is 154. Right? So that is not important. This column is not important or this one is not important. Just they are mentioning the records only. So we required only with respect to the precision and recall. And in few cases, we require the F1 score. In which case we require the F1 score, we'll see in the further. As of now, that is not important. So just you can ignore. In the further class, we can see that. Is that clear, guys? Now, coming to the next one, with respect to how to identify the best random state number in train test split. Okay, since everyone are asking this question, how to identify the best random state number. So if you go with this same example, whatever example we have done just now, that is a diabetic data set. Now I have done with respect to first one is I'm going to load the data. Okay. And after that, I'm going to take this common, everything are common. Up to here, there is no difference. X and Y. Now, after selecting X and Y, now I want to go with the X train, comma, X test, comma, X Y train, comma, Y test, and train test split of X, comma, Y with test size of 0.2 and random state of one number. I have to lock one number. Now, how to lock that number? That is the question. How to identify the best random state? Now, what I'm going to do is from sklearn.model selection, I'm going to import the train test split. From sklearn.linear model, I'm going to import the logistic regression. From sklearn.metrics, I'm going to import the accuracy score. And from the sklearn.model selection, I'm going to import the cross validation score. These four of them I'm going to import. Now, what I'm going to do here, just observe clearly. For I in range of 0 to 101, I have written up to 101. In your case, you can try with, if you would change this one to 1001, means 0 to 1000. So here 0 to 1000, I'm going to split x comma y with a test size of 0.2 and random state of first 0. It will take 0. It will split with respect to random state of 0. And log, it is going to apply the logistic regression. And after logistic regression, it is going to fit on the X train, Y train. Just observe this, whatever the code just now we have completed a few minutes back. Where is that? Just now we have completed this one, right? In this, I have fixed with 0. I have fixed with 0. Now, for example, if I want to bring everything in one cell, how to do this? This one also I'm bringing in this cell only, Amma. I'm keeping here only. Okay, I'm writing here only. Whatever the cell is there, that one also I'm writing here itself. Okay, and I'm removing the these words, modeling, prediction, and evaluation models. These words I'm removing. And whatever the first one is, try and test it. And this is second import. I'm copying here. And next one, what is the next one? Accuracy score. That also I'm copying here. Cut, and I'm copying. And cross validation score. This one also I'm copying here. Is that okay? Only modification, copy and paste. And I'm bringing everything to like this. Is that okay? What I have done? Just I have brought everything into one cell. Nothing I have done. Earlier it is very clear. First train test split is very clear. Import and you have done. Followed by modeling is very clear. Followed by prediction is clear. Followed by import accuracy score. And after that evaluation is there. Now in this case, what happened is all the imports I have brought to one case. And train test split I have done. And I have done the modeling. And after the modeling, I have done the prediction and accuracy. Same to same. No difference. Is that okay? This one? First, this one is okay. Now inside this, here I have fixed the random state of 0. After the random state of 0, first I'm taking the random state of 0 and I have got the train accuracy, test accuracy, CV. Now I'm changing this one to 1. And I have got train test CV. I'm changing this one to 2. Train test CV. I'm changing this one to 3. And I will get the train test CV. I'm changing this one to 4. I will get the train test CV. I'm changing this one to 5. Train test, train accuracy, test accuracy, and CV score. Next, I'm changing this one to 6. Like this, instead of doing manually, I'm using the for loop. The same thing, I'm writing the for loop. Now, what I have done, the first 0, followed by 1, followed by 2, followed by 3, I'm writing the for loop for this. For I in range of 1, 6. If I want to include 6 also means 1, 7. Now what happens in this case? In this case, what happens? First 0, followed by 1, followed by 2, followed by 3, followed by 4, followed by 5, followed by 6. What I have done earlier, manually I have done the same thing. It is going to be done. So this everything, whatever I'm having, this should be inside the for loop. So I'm moving to the one space like this. Now what happens? First it is going to try the for loop for I is equal to 0. After that, I is equal to 1, I is equal to 2, I is equal to 3. Like this, it is going to calculate everything. So for I is equal to 0, this is I is equal to 0. This is I is equal to 1. This is I is equal to 2. I is equal to 3. For random state of I is equal to 4. I is equal to 5. And similarly, I is equal to 6 and I is equal to up to 6. First one is 0, 1, 2, 3, 4, 5, and 6. For each random state of 0, 1, 2, 3, 4, 5, 6. Now, out of these 6, assume only 6 are, these are the assume. In this, which one is best? How you can conclude? How you can conclude in this, which one is best? Directly, we can't see the test accuracy only. We have to see whether the train accuracy is equal to test accuracy. At the same time, test accuracy is also equal to CV. If both of the conditions matches, if this both conditions satisfies, and if whichever the condition satisfies this one, first I have to identify. At the same time, CV, the maximum which is having the test accuracy, that one I'm going to identify. Now, out of these 6, identify which is having the train and test is almost same. Tell me which are the numbers. First, train and test. This train and test both are same. Train and test within the plus or minus 5%. This test and train are same. At the same time, test accuracy is equal to your CV. Plus or minus 5% only. It is in the range of same. Okay, this is satisfying. This one, satisfying. This one, satisfying. This one, satisfying. This one, train accuracy, test accuracy, and CV, satisfying. This one, satisfying. This one also satisfies. Now, all of them are satisfying. Now, within this, which is the highest test accuracy, which is having the highest test accuracy? Out of all of them, which is having the highest test accuracy? Everything of say. Done. Now it is different. Everything are same only, right? Yes, correct. Now everything will be different. Now you can see the difference. What is the difference? It is more than 5% or less than 5%. And you can see the difference, whether it is more than 5% or less than, more than 5% or less than, more than 5%. Like this, you are going to identify which is not having more than 5% difference. First step. Second, at the same time, test accuracy should be equal to CV also. Again, out of all of them, whichever satisfies the condition, within that, which gives the maximum test accuracy. That is the best random state number. The same code I have written here. Just observe. First, I'm going to take a random state of 0 to I value of 0 to 101. Now, first it is going to take a random state of 0. And it is going to apply this entire things. After applying that one, I'm going to calculate whatever the train accuracy is there. This I'm going to append into the empty list. Whatever the test accuracy is there, this I'm going to empty list. And CV is there, this I'm going to append into an empty list. Now total how many values I'm going to get? Total how many? From 0 to 101. I'm going to get from 0 to 101. That is nothing but 0 to 100 with a random state of 0 to 100. Now, using this one, I'm going to create, just observe this. I'm going to create a data frame using the 100 values. Whatever the 100 values I have got, I'm going to create a data frame. First, it is going to apply the 0, followed by 1, followed by 2, followed by 3 like this. It is going to check everything. And using that one, I'm going to create a data frame. How to create a data frame? pd.dataFrame, and in the dictionary, keyword and the list. Keyword, list, keyword, list. List of values, 100 values here, 100 values here, 100 values here, and I'm going to create this one. Now you got the total, all the for different random states, train accuracy, test accuracy, and CV. For different random states, train accuracy, test accuracy, CV. Now how to identify which is the best? Now I'm going to write here the condition. I'm going to write the condition. What is the condition I'm going to write? Just observe this condition. Condition is whichever the data that is train minus test, it should be less than or equal to 0.5. 0.5, that is between these two. Whatever these two are there, between those two, the difference should be between 0.05. The difference should be between 0.05. And at the same time, test accuracy minus CV also, it should be between 0.05, 5% difference. Now I'm identifying which record satisfies those. Again, it will take time to do that one. Okay. So now I'm just identifying the records which satisfies the condition. Whatever the condition I'm having, this condition. What is the condition? Just observe the condition once again. Condition, this is the condition number 1. This is the condition number 2. What is the condition number 1? Condition number 1 is train minus test should be, difference between both of them should be 0.05. That to absolute value. I'm not going to consider the normal, absolute value, either plus or minus 0.05. 5% should be the difference. At the same time, end test minus CV, the difference should be between 0.05. I'm identifying how many records satisfies, means 87 records satisfies this condition. Basically 101 records are there, out of which 87 records satisfies the condition. Now within this, how many 87 records, I'm going to select the test 1. I'm going to take the test column. This is the test column. And within this test column, I'm asking the argmax. Now what is meant by argmax means it is going to give me the maximum value of the test, which is having the maximum, the index number. It is going to give me the index number. This is the best random state number. 15 is the best random state number. So 15 will give the, out of all of them, 15 will give the best one with the test accuracy as the maximum without having any kind of overfitting or underfitting. In this way, you can identify the best random state number. Is that clear? Clear, guys? If it is not clear, you ask. Should I explain once again? Just forget about remaining for loop. First random state of 0 only. Let us take for 0. For 0, you are calculating the train accuracy, test accuracy, CV. And after calculating for random state of 0, you are saying that whether it is a good model or bad model, how you are going to decide? How you are going to decide? Test and should be equal to your train within plus or minus 5%. Means the difference between test and train should be between plus or minus 5%. That is only the meaning, right? This is the condition number 1. What is the condition number 2? Test should be equal to your CV within the plus or minus 5%. That is nothing but test minus CV. Whatever you take, it should be between plus or minus 5%. This is condition number 2. This is the condition number 1. This is the condition number 2. Now for random state of 0, you are going to calculate the train accuracy, test accuracy, CV, and you are going to check the 2 conditions. Now after that, what you are going to do? For random state of 1, again you are going to calculate the train, test, CV, and you are going to check the 2 conditions, condition 1 and condition 2. 2 conditions, condition 1 and condition 2. Now after that, you are going to take random state of 2. And you are going to calculate the test accuracy, train accuracy, CV. Again, you are going to check the condition 1 and condition 2. For each random state, you are going to do this one. The same thing I have done using the for loop. Just I have changed the for loop. Instead of doing manually of 0 and 1 and 2 like this manually, I have used the for loop. Now using the for loop, what I have done is for each random state number, I identified the train accuracy, test accuracy, CV. For each random state. For every random state, I identify like this. Up to here, it is clear. And how I am using the empty list, and in the empty list, I am appending every time. Train accuracy, I am applying in the empty list, test accuracy separately, CV separately. And how to create a data frame is pd.data frame of first column X with a list of 1, 2, 3, 4, 5. If you write like this, what is the answer you are going to get? X 1, 2, 3, 4, 5. This is the answer, right? Similarly, I'm writing the train and the train list. Whatever the train list is there, I'm going to get the first column. Using the second one, second column. Using the third one, third column. Like this, I'm creating the data frame. Is the creation of data frame is clear? Up to here, it is okay. Anyone has any questions up to here? Please ask if you are having any questions. Is that okay? Now, once this is done, now in this total 100 random states numbers are there. Now, out of which, based on the condition, here I have just loaded the answers. Whatever the train test accuracies I have checked. I have not checked the conditions. Now I'm writing the condition. What are the two conditions? First condition, the difference between train versus test, the difference should be between 0.05. This is the condition number 1. I'm asking, this is the condition number 1. This is condition number 1. Now you can see how many of them are satisfying the condition number 1. Now similarly, condition number 2. This is condition number 2. Now both the conditions, I'm writing in between end. End means this condition should be true. At the same time, this condition also should be true. When both the conditions are true, it is identifying only those records. It is identifying only those records. Up to here, it is clear. These are the 87 records which satisfies both the conditions. If you want, you can check. You can check the difference between these two. What is the difference between these two? Less than 5% only. Difference between these two also less than 5%. So it is identifying the records which satisfies the two conditions. Condition number 1 is train and test difference should be plus or minus 5%. Test and CV should be difference is plus or minus 5%. After identifying this one, now 87 random state numbers are satisfying your requirement. Now out of these 87, which one you are going to select? Which random state you are going to select means which gives the maximum test accuracy. Now within this, what is the test accuracy maximum? For example, I'm storing this one in a new data frame called as yes. Some data frame called as yes. Now within this, for the test data, what is the maximum value? How to identify? How to identify the maximum value of test column? How to identify? Data frame, and you have to take the column name dot max. Dot max will give the maximum value. Now this maximum value, whatever, this is the maximum value, test accuracy maximum value, but I want the index number. I don't want the maximum value. I want the index number of the maximum value. If you want the index number, what we have to do is argmax. That is the index number. Max gives you the maximum value. Argmax gives you the means index portion of the maximum value. So in this way, I have got the index portion. Now index portion of 15 is the maximum value, means 15 is the best random state. Because I have started from the 0. Here I have taken directly from the 0. So starting with the random state of 0, followed by random state of 1, 2, 3, 4, like this. So random state 0 records are stored in the 0 index number. First record will be stored in the first index number. So index number and random state numbers both are matching. So I don't need to worry about that. So the best random state number is 15 is the best random state for this record. So now if you observe here, earlier I have taken the random state is equal to 0. Here I have taken the random state is equal to 0 and I have got the train accuracy, test accuracy, this one. Now when compared to this one, now if I'm changing this random state to instead of 0, 15. Now 15 is the best random state number, which is not having any kind of problem. Is that clear? Done? So just you can check and you can go through this, and I'm going to upload the notes of the logistic regression along with the best random state number. How to identify the best random state. Just I'm going to upload this both the notes. Please go through this. And if you have any questions, you can please ask. Just a minute. Classification. Till now, I have not uploaded classification notes. Huh? Okay, okay. Here, number was not mentioned. Okay, done, done. So logistic regression nodes code, and along with that data set, today's class data set, that is, what is the data set we have work? And best random state code also. I'm uploading the best random state code also. And KNN nodes and KNN code. KNN coding we can continue in the next class. And along with that data set, right? Diabetics data set. Yes, I have uploaded the notes. Please go through this. Please check, guys. I have uploaded the notes also. If you have any questions, please type. Online students. Yes, if you want to take that random state, best random state number, you can take that for loop. Every time you copy the for loop only. Whatever the code I have shared you, just you can copy that code and you can paste, and you have to change the model name. That's it. Remaining everything will be the same now. Only the model name will change. And that too, you don't need to calculate for each and every model. For classification, logistic regression, whatever the random state number you have got, that one you can use for all the things. Right? You don't need to calculate separately. If you're doing only one algorithm, is for that algorithm you're going to apply. But if you're calculating for all the algorithms, if you're applying as a capstone project, for the base model only, you can calculate the best random state. And it can be used for the others also.